We've encoded boxes with variables, but variables still, by default, have a bit of a funny behavior. So here we've got a function swap. The name suggests that when we call it down below with a and b, we'll actually swap the values inside a and b. So the result when we ask for a at the end might be 20, but that's not actually the semantics that we get. The assignment and swap doesn't affect the a on the outside. It's swapping two different variables that get created when we call the function. Some languages have decided that they really don't want this behavior. They really want 20 to be the result. And so that's what we'll explore next. We've been implementing something called call by value for function calls, and we'll see an alternative known as call by reference. Here's one more example. This is the fill function that we've seen before. Maybe fill assigns 5 to its argument, and down below we create a variable a, its value is 0. We call maybe fill on a, and then we get the value at the end. And the result here is 0. Well, what if we want the result to be 5? Let's take a closer look at this program to see why we get 0. So on the top, we've got the original code with variables. Down below, we've got the code using boxes, which makes it more clear why it behaves the way that it does. So inside the function, we have a set box assigning value 5. A is declared as a new box. And then here's the key. When we call maybe fill, we're calling it with a newly created box that has the value of a on the inside. So the set box inside of the function affects our new box. It does not affect the original box. When we ask for the result of a at the end, we get back 0. A hasn't changed. With call by reference semantics, the difference is to not create a box when we have a function call here. So this a should go directly into the maybe fill function, and now the set box can act on that a. So when we do the unbox, we'll get the value 5 at the end. Again, this semantics is known as call by reference, and what we've got so far is known as call by value. Call by value is generally the better choice, but it's good to know about both. One more thing, the name call by reference can be a bit confusing. So for example, Java is a call by value language, but one of the kinds of values that you can pass into a function call is a reference to an object, but it's really not a call by reference language. Moving on. If we want to change our interpreter to implement call by reference, true call by reference, we need to change how applications work. First thing, we need to match on the argument to the function call. If it's an identifier sitting there, strictly an identifier, then we don't evaluate it right away. Instead, we match on the value of the function, make sure that we have a closure, and then we extend the environment. Only the environment, not the store. And we extend it so that the function's argument n points to the same location that that identifier s points to. With that, we've established a direct link from the name of the function argument to the location that we passed in at the application site. We don't create a new location inside of the store, and we're ready to go. We can interpret the function body. Then, down below in these dots, we need to handle applications in the normal case, where we evaluate the argument and then pass in the value of that in a new location to do the function call. So if this seems a little bit ad hoc and suspicious, inspecting the argument, well, you're right, it is. This is not following the design recipe. And this reflects the fact that call by reference is more difficult to reason about. When your code applies an identifier as opposed to some other argument, it will behave differently in call by reference. And this ad hoc behavior is why call by reference is generally uncommon among language designs.